Hi, my name is Suhwan Kim. So today I'm going to introduce my research project associated with the expectation effect on the pain experience. So before the beginning, we are here now, so a very different time zone. Sometimes I cannot quickly respond to your comment or something is because of that, so please understand. Many studies have suggested pain is not just a collection of sensory input, but an experience to integrate through the dynamic cognitive process of prior and contextual information. There are many types of research to reveal how prior information influences pain experience in the behaviorally or neurally. So some researchers provide or manipulate those very different types of cue relate information of similar stimulus like color visual cue or conceptual running or uncertainty like that. However, so many studies have only focused on after and before process, like the before rating their expectations or after rating their pain experience. Like the dynamics in integration process have less study in the field. So to investigate temporal dynamics of this process, we apply the trajectory race measure into our study. It already used across many fields to liberate cognitive process. So like the stereotype or processor decision making or full choice task. So in this study, our goal is to examine the temporal dynamics of the intuition process of pain prediction and perception in the brain. And for that, we employ this trajectory-based measure and temporal mediation framework to utilize this kind of trajectory-based measure. So in our study, the number of participants is 59. The experiment consisted of 108 trials. Trial structure is this following disorders. So first, participants see the social cue. It does mean that previous participants' pain ratings for the comic stimuli, and then participants rate their predictions of how painful in real time by experiencing a similar stimulus. In this case, a trajectory-based measure would be a good scale tool for continuously participant prediction rating. And last, the participant also rate their overall pain experience in a game. And that's it. So I think you can understand trial structure through this video. Now this is a behavioral research. So this plot is a group. So for thick lines are each group average and thin lines are each individual's average. And the line colors means each experiment conditions. So let's see the very light red colors line. So the stimulus level is high and the social cue level is low. The lines means that the participants first they'll leak their prediction towards social information. At around 7 seconds, the ratings start to move towards stimulus intensity. So I think that we think this means that the trajectory measure would be reflect the participants' cognitive integration process. So we tested the experiment condition effects on a trajectory by performing the time by time vertical level GLM. So the y-axis is beta coefficient, x-axis is the time. So the Q has more effect on the early prediction trajectory than stimulus intensity. But as time goes by, this effect is getting decreased. On the other hand, stimulus intensity is getting increased. But at the end of the trajectory, stimulus intensity effects are stronger than Q effect. Based on this result, we can conclude that Q and stimulus intensity show the time-varying effects on their cognitive process. Next, I will briefly introduce what is a temporal mediation analysis. It's quite simple. This analysis means that all the time combination will be performed by the mediation analysis. In this case, the brain activity, this means 45 TRs, and the continuous prediction trajectory means 32 TRs. is used in here. So, all combinations are covered by the mediation analysis. So, we think we will be interpret this relationship, and it could be address temporal dynamics of pain experience. For the definition of temporal relationship, we use data-driven ways to independent component analysis. So, except for the interpretable combinations, we did IC analysis to identify the significant relationships. We use only top 2.5% of the temporal weight for defining temporal relationship because our goal is to find the significant temporal relationship. So to find significant brain barriers for each time domain. There are results for Q effects. So most temporal patterns, temporal domains are associated with the early period of brain activity and Q dominant and integration period of trajectory. And then this each colors mean each temporal domain. So brain regions within the user attention and prompt parietal networks mediate the Q effect at early stage like IPS, VFPFC, DLPFC. So these lesions mediation effects were weakened over time. But on the other hand, for the stimulus intensity effects, the temporal relationship usually associated with the end period of trajectory rating. It is similar to the behavioral analysis. So the stimulus intensity was usually mediated by the smartphone's sensory network like Dojoprost insula and S1, S2 were, yeah. And dorsal attention and frontoparietal networks lesion also mediate this stimulus intensity like DR, PFC, or premolar. We identify the brain barriers integrating prior information into pain perception using a new scale. And using this temporal mediation analysis framework, we identify the temporal dynamics of brain mediation for the cue and stimulus intensity effects. So through these novel tools and analysis method, this study helps us to better understand how different brain systems integrating the prior product information into pain perception, hopefully. So thank you for watching this video. If you have any comments or feedback, uh, please leave your message on the chat or mail or anything. Thank you.